Am I audible, Pooja?
Hello, Dr. Priyanka. I have joined.
Okay. Okay, ma'am. I'm starting. Good afternoon, everyone. On behalf of organizing team ICHE 2023, I, Dr. Priyanka, welcome you all in today's live session. On this occasion, it gives me great pleasure to introduce our chairperson of today's live session, Dr. Kirandeep Kaur. Dr. Kirandeep Kaur is working as an assistant professor in Khalsa College, Amritsar since 2016. She had a teaching and research experience of around 8 years. She has been awarded with international travel grant by DST for presenting her work in an international conference, BioCat 2012 in Hamburg, Germany. Also awarded with Best Paper Award by RSC London. Her expertise is in the field of asymmetric catalysis, organic spectroscopy. Her area of research is organ catalysis or biocatalysis. She has published around 8 research papers in various national and international level journals. She has presented her research work in more than 15 conferences and workshops of national and international level. She has authored one book and she has supervised 16 students for MSc project thesis work. Welcome, Dr. Kirandeep Kaur ma'am. Now I am handing over the session to Kirandeep Kaur ma'am for further proceeding. Over to you, ma'am.
Okay, thank you, ma'am. Thank you. Welcome to all the participants for your presentations. I hope you have prepared your content very well. So, shall we start? Hello, Dr. Priyanka.
Yes, ma'am.
Have all the participants joined?
No, ma'am, you have joined. We can start.
Okay. So, is Dr. Amit there? Dr. Amit Kumar Rawat.
No, ma'am, Amritsar is not.
I think he hasn't joined yet. Okay. So, next is Nagarjuna. Kurakula Nagarjuna, a postgraduate student here.
Yes, ma'am. Good afternoon, ma'am.
Oh, good afternoon, Nagarjuna. So, how are you?
Yes, ma'am. I'm fine, ma'am. What about you, ma'am?
All good. So, what is your research topic and what kind of presentation you are presenting here?
Ma'am, can I on my video?
Yeah, sure.
Yeah. Good afternoon, ma'am.
Good afternoon.
Yeah, ma'am. My research is based upon the synthesis and the spectral characterization of cytosine derivative bearing acetylpyridine, ma'am.
Okay.
Polymer containing pyridine group, ma'am.
Okay. So, have you prepared your presentation?
Yes, ma'am.
Okay. You can present your work presently.
Sorry, ma'am.
You can present your work. You can start with
Okay.
your presentation.
Okay, ma'am. Ma'am, is everything visible, ma'am?
Yeah, it's clearly visible.
Yeah. Good afternoon, everyone. My name is Nagarjuna Kurakula
Good
from Andhra
afternoon.
Pradesh. I am going to present my research work on the synthesis and the spectral characterization of a cytosine derivative and bearing acetylpyridine. Coming to introduction, we already know cytosine is a biopolymer and non-toxic. This introduction highlights the significance of cytosine as a versatile, biodegradable, and non-toxic polymer. It underscores the importance of the cytosine derivatives, specifically those containing acetylpyridine, and how they tailored qualities of for applications in biomedicine and environmental remediation, especially the modification of NN trimethyl cytosion and 6-orthochloro trimethyl cytosion is discussed with structural confirmation methods like IR and SEM. And these derivatives hold a various challenges in drug delivery and wound healing and environmental science.
Yes.
Coming to my work, ma'am, in this synthesis process, cytosion initially dispersed in N-methylpyridine, and this is the crucial step because of to make a homogeneous solution of cytosion and stirred, followed by the addition of sodium iodide and methyl iodide and sodium hydroxide, leading to the formation of trimethyl cytosion through a reflex reaction. Then we got trimethyl cytosion. Subsequently, ma'am, it is reacted with the chloroacetyl chloride in DMF to create NN trimethyl orthochloroacetyl chloride, acetyl quaternary ammonium salt cytosion. Here, then we will get the CTCS AP. We can see that scheme too, ma'am.
Yes.
Then after the CTCS is combined with 2-acetylpyridine in DMSO at an elevated temperature and resulting in the formation product of desired cytosion derivative. Finally, the product is obtained through the precipitation and freezing drying. Freezing drying. To verify the above products, IR was performed, ma'am. First, we observed a peak at in the region of 3, 4 to 7, indicate the OH stretching frequency, ma'am. And moving to the range of 2876 is a strong indicator for the presence of the amino groups in the compound. And we observed a peak at 1380, indicating stretching frequency of CO bonding, bridging bonding, which may imply the presence of oxygen containing from groups. The last one is a peak at range 1080 compounds to CN stretching frequency, which suggests the presence of the nitrogen containing groups. And the OH peak is like we can see, ma'am, CS, TMC, CTCS, CTCS, AP, whatever I prepared, the OH peak will appear at 3,400, 3,400 to 3,500 range, ma'am. And coming to TMC, here we can see the CH stretching at 2942 and moving moving to the range of 2870 to 2942. We can see multiple peaks associated with asymmetric and symmetric stretching frequency of stretching bonds, man. And CO stretching, uh, we observe a peak at 1309, indicating the stretching frequency of CO bridging bonds, which may imply the presence of oxygen containing groups. And last one is also same for cytosion. Here the different one is, ma'am, the pyridine indicating peak, ma'am. Last one CTCS AP. Here we can observe the new peak is appear. (1423), ma'am. The pyridine ring is confirmation here. Moving to STEM and EDX studies, ma'am. we can see the surface of the chitation is like a very smooth and non-porous, ma'am. Compared to CTC, chitation, TMC is more porous than the chitation, and the CTCS, the porosity of CTCS is decreased, and here we observe the regularity and the dendrimer morphology, ma'am. And the final one is there is no porosity, and the shape is dendrimal spherical shape, ma'am. Here we can see, ma'am. In the conclusion, ma'am, the synthesis and the characterization of chitation derivative, including acetylpyridine bearing variants of versatile materials with applications spanning biomedicine and environmental science. These derivatives hold promise in addressing current challenges, paving the way for the future research to unlock their full potential in address complex issues in this field. Coming to acknowledgement, I'm very grateful to my professor, Dr. Himanshu, ma'am. She is always supported to me, and this is here is the reference for my project.
Okay, very nice, Nagarjuna. So, have you done this work at your own?
Ma'am, this is my academic project. So I think that I should move on further also. So I just do it.
Okay. So, have you tried some other methyl derivatives, or you have only done the methylation at the end position? You have
Only,
tried any other alkyl derivative?
ma'am, according to my knowledge, I searched a lot of papers, but no one used that acetylpyridine attacking on the CN position. So I thought
Okay.
it's like a new derivative. So that's why I'm introducing to you people.
Okay, you are introducing that acetylpyridine group.
Yes, ma'am.
No, I am talking about the N trimethyl group. You have three methyl groups at the end substitution here.
Yes, ma'am. These already people. Some people are already did this thing.
So that what I am asking about, that you have tried some other alkyl group, or these are the actual moieties?
No, no, ma'am. These are the actual moieties.
Okay, okay, nice. And one more thing I want to clear out, that have you done the molecular docking for these? Have you tried for that?
Actually, I want, ma'am, but during my masters, I don't have that subject actually.
Okay.
So I'm also I want to discuss with this DFT or drug designing
Yeah.
purpose.
So that's what I want to share, that you should go for the DFT or other molecular docking systems.
Yeah, I'm also tried, ma'am, but I don't.
And that's a good work.
Yes,
Okay. And this is very nice, Nagarjuna. Okay. Thank you.
ma'am. One more thing.
Yes.
Ma'am, is there any time to discuss end of the session?
Is there any time? I don't know. If we will get the time, we will definitely discuss.
Okay, ma'am. Thank you.
If we will get the time after the presentations, then we will discuss it.
Okay, ma'am. Sure, ma'am.
Okay. Thank you. So, Dr. Amit Kumar Rawat, faculty member, has he joined?
Nida had joined.
Nida Andali?
Yes, ma'am. Good afternoon, ma'am.
Okay, Nida. Okay, good afternoon. You can present it.
Is it visible, ma'am? Good afternoon, ma'am. Today I'm going to present my poster presentation on topic phytochemical analysis and identification of bioactive constituent of Brunner liceniosa seed. So basically for my research topic, I have chosen a medicinal plant whose name is Brunner liceniosa, commonly known as Shivlingi plant. So this plant is very common medicinal plant and it's almost in extinct condition. This plant is traditionally used for traditionally used to treat various diseases, especially in Ayurveda and folklore traditions. It is used to treat cholera, bronchitis, constipation, diabetes, snake bite, abdominal disease, and all. So basically, I've chosen this plant to study its phytochemical components which are present there, for which I have used different methods to identify its phytochemicals present in it and its bioactive constituents that are present in this particular medicinal plant. So what I have done for this, I have taken Brunner resinosa seed and sun dried it, clean and ground it into fine powders. Then I have soaked this fine powders for 48 hours in ethanol. Then they are filtered and then I have filtered it and evaporated in rotary evaporator. The residual that I yield that are basically the ethanolic extract of the seed. Then I have done for phytochemical analysis, I have done preliminary analysis, then FTIR and GCMS. For all these three methods, standard protocols are followed. So my results are for preliminary test. These are the phytochemicals that are present in it. That is carbohydrate, fatty acids, steroid, flavonoids, saponins, phenols, and amino acids. So basically, this flavonoids and phenols are present to show that this medicinal plant is of active is beneficial for us for future study. So I've also performed this FTIR analysis, and different stretches and peaks are found in this. So at in my study at 3 to 89.26, that is there is a stretching, that is OH symmetric study. OH symmetric stretching is found. Then there is a stretching is at this point 2917. So this shows the CH3 stretching. Then 1712 stretching, there is a carboxylic group present, shows, and then there is a 130. Sorry, 1030. This show the vibration. There is a vibration of glycogen, and around 800 to 600. This shows that there is a halogen group present in this particular medicinal plant. Then I have performed GCMS analysis of this particular ethanolic extract of the plant, and what we have found out that there are almost 47 compounds present in this particular ethanolic extract. So the compounds that are found, maybe they can be of medicinal use. What I have found that this particular plant, Brunner liceniosa, is a good source of phytochemicals, and this particular plant can be used to identify many novel chemotherapeutic agents that may be in future used to treat can be used for different therapeutic agents.
Okay. So that's all, Dr. Nija?
Yes, ma'am.
Okay. Sorry. What I'm thinking about that you have very pure IR spectra. So have you done the column chromatography firstly?
Yes, ma'am, I have done that column chromatography.
So how many columns do you expect from the phytochemicals? Because you can't separate the phytochemicals with a single column.
Yes, ma'am.
So how many columns you have undergone?
Ma'am, I have undergone 3 columns.
Okay. So what kind of elements you have used to separate them?
Sorry, ma'am.
What kind of eluent solvent systems you have used in case of column chromatography? Because this is a very pure spectra. Even a pure organic compound doesn't get such kind of a spectra. FTIR.
This FTIR of this what you are saying, that pure spectra, it's not of column.
No. Yeah, I know that the ethanolic extract you have extracted, it
Mhm.
may contain number of phytochemicals because
Yes.
there may not be a single compound there.
Yes, ma'am.
So how you have separated such a pure compound? That's what I am asking you.
Ma'am, actually, sorry, ma'am, I am just not getting what you are saying.
Actually, beta, I'm not saying something. I am asking about you have done only the ethanolic extracts of the plant seeds. Okay.
Yes, sir.
Okay. So in the ethanolic extract, how
Mhm.
do you know that there is a single compound that is showing this FTI spectra? Because it may contain number of compounds. When you are taking the extract from a compound from a plant, it
Mhm.
may contain number of compounds there.
Yes, ma'am. Actually, these are showing for that reason I have performed GCMS analysis
Okay.
for
So
that.
FTIR is not of that particular compound.
It's of that particular ethanolic extract only, but that's what I'm not satisfied with. That's why I have undergone for
Right.
GCMS analysis so that I can get more clear cut analysis of which are the phytochemicals present there.
Yeah, because it is not very
Hmm.
sure that this is the compound. Okay.
Yes, ma'am.
Okay, beta.
Yeah.
That's good.
Thank you.
So, what are the yields you have got in the ethanolic extracts?
Ma'am, basically, I have got bioactive constant that's what you are asking.
Yeah.
Ma'am, actually, ma majority I have got vitamin E forms like alpha and beta.
Okay.
Yeah, and there is a glycogen also present, and many different flavonoids are also there.
That's what beta I am asking you, that how you have separated so many compounds, flavonoids, vitamin E, and all that.
Ma'am, after GCMS analysis, I got the list of that whole library of 47 compounds.
Okay.
Then I have searched from them that which particular group they are present. So from there, I just came to know which are the compounds there.
Okay. So
Mm.
you have not separated by the column chromatography.
No, 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 I haven't
Okay.
separated economic
Oh,
chromatography.
that's good.
Mm.
Okay, beta. Okay,
Mm.
thank you.
Thank you, ma'am.
Hello, Mr. Sudhir Babu. Yangala Sudhir Babu, PhD research scholar. Are you there?
Actually, ma'am, the next participant is Yangla Shudhir Babu.
Yeah, Yangala
He's
Sudhir
there, huh?
Babu.
He's there, ma'am.
Okay. Let
Hello,
us
good
start.
afternoon, ma'am.
Good afternoon, Dr. Babu. So you are a research scholar in Delhi University itself.
No, ma'am. Actually, I am from Central University of Haryana, ma'am.
Okay, so good.
Ma'am, my slides are visible.
Now, yes, it's visible.
Yes, ma'am. Shall I start now, ma'am?
Yes, you may start.
Respected chairperson and my dear fellow participants, a very good evening to you all. My name is Y. Sudhir Babu. I am from Central University of Haryana. Today, I am going to present a review study on my PhD work, which is related to the one of the global parasites, that is on current implications of Toxoplasma gondii in human health and diseases, and update. Before going into details about my work, I would like to introduce about my parasite of interest and its causing diseases in humans. Toxoplasma gondii is an intracellular zoonotic apicomplexan group parasite. which is causing serious neuropsychiatric diseases like schizophrenia, paranoia, and delusions, along with the other common symptoms like swollen lymph nodes, headache, fever, etc. So the first parasitic potential of Toxoplasma gondii has been reported in congenitally infected children in 1920 and in 1930. Later in 1950, this parasite was observed by infecting in animal livestock such as goats, sheep, cattle. So, according to World Health Organization 2021 report, it has been recorded nearly 1 million Toxoplasma cases are going to record per year.
Hello.
In India,
Hello.
yes, ma'am.
Sorry, Babu. I want to ask you, your presentation is not working. It is on the single slide.
Yes, ma'am. Yes, ma'am. Right now, I'm explaining first slide only, ma'am.
Okay. You are explaining per slide.
Yes,
Okay.
yes.
Uh,
So in India, nearly 57,000 children are going to born with this congenital toxoplasmosis. Nearly 22% of the pregnant women get infected with this toxoplasmosis per year. Now we will see the reports according to the newsletters. So these are the reports in current scenario. This is the report published by the Indian Express newsletters. Here they clearly mentioning that
Hello.
one in three.
Sorry to interrupt, but your reports are not visualized. Where are the reports?
Ma'am, right now I am presenting in second slide, ma'am. Reports
But
of teeth.
it is not working on the screen. It's showing only the title screen there.
Should I begin from first onwards, ma'am?
Yes, you can.
Ma'am, my slide is visible now.
Yes. Now it's visible.
So these are the reports according to the Indian Express newsletters. So here they are clearly mentioning that one in every three people they are getting infected with this parasite, and the person who got infected with this parasite they are getting suicide attempts in humans. So these are the references published in 2012 and 2022. So for looking into the ultrastructure of this parasite, here in right side, I have mentioned about the cartoon. So this is the ultrastructure of a parasite. Here we can see the cell organelles like micronemes, rope trees, dense granules, plasma membrane, etc. With the help of these rope trees and micronemes, the parasite is going to infect and invades into the infected host, and it may spread into the throughout the whole body of the humans. Ma'am, my slide is visible now. Hello.
Sorry, your third slide is visible.
Hello, your slide is visible, but it is the same slide you have shown. Second slide, na? Reports
No,
of
ma'am.
T. gondii.
No. Next slide is
It's
life
not
cycle.
moving. No, it's not moving actually.
Some issues, ma'am. I don't know what.
No problem. You can change it.
Ma'am, now
Yes, now it is visible.
coming to the life cycle and transmission of this parasite is having complex life cycle. It is having two stages. First one is enteric cycle and second one is exoenteric cycle. In biology terms, enteric cycle means the cycle of the parasite which completes inside the small intestinal portion. So exoenteric cycle means in biological term, apart from the other than the small intestinal part like skeletal muscle tissues, brain and remaining other body organs like liver, lungs, kidneys, etc. So the cycle was first initiated with the cat, gastrointestinal tract of the feline host, that is cat. There the parasite will converted into bradyzoids, then it will undergo merozoids. There, after merozoids, then it will converted into microgamete and macrogamete. Then, after getting fertilization of these both gametocytes, then ultimately it will convert it into oocyst. This oocyst is the present in the fecal matter of the cats. The contaminated food material or the soil which may uh, contaminated with this oocyst, it will from this contaminated soil, this parasite is going to transmit through the contaminated food material, or the persons who ate improperly cooked meat such as birds or chickens. From that way also this parasite is going to infect into the humans. Whenever the pregnant woman or the person who got pregnant, during that time, that the infection will be passed from the pregnant woman to another fetus also. So there, in case the fetus escaped from the abortions during the situation, birth of the fetus, the person will get hydrocephaly or mental retardation, such kinds of activities. So after entering inside the human body, this parasite will turn into brachioids. These again brachioids may turn into sporozoites. Again, sporozoites may turn into tachyzoids. Slowly, these tachyzoids will enter into throughout the body organs such as heart, kidneys, brain, and liver, lungs, etc. So when the person will get died, then this transmission as well as parasite life cycle is also going to end. Coming to the objectives of my study, we are having two objectives. First one is to identify the potential role of Toxoplasma gondii in developing health impediments related to central nervous system, hepatic, pulmonary, and cardiovascular and congenital anomalies. Second objective is to evaluate the Toxoplasma gondii mediated disease severity in diagnosed individuals with diseases related to the central nervous system, pulmonary, hepatic, and cardiovascular congenital anomalies. Actually, we followed this methodology. We followed the search database such as Scopus, PubMed, Web of Science, JSTOR, DOAJ, and Google Scholar. The search terms we used is Toxoplasma gondii, hepatic illness, CNS, that is central nervous system, cardiovascular and kidney related diseases. In total, we searched nearly 170 articles. In that, we excluded 38 articles and we included 132 articles. So we included only the articles from the peer-reviewed journals, T. gondii with seroprevalence reports, along with the diseases reported by the T. gondii diagnosed individuals. And we excluded the articles older than the 2000 year, the articles which are not indicating clinical reports. These are the excluded articles. We referred 132 articles and we have prepared the review study. Outcomes of my study is totally we distinguished and we differentiated the different organ systems and their diseases got by the Toxoplasma gondii. In coming to the central nervous system, uh, we isolated nearly Parkinson's disease, Alzheimer's disease, Toxoplasma encephalitis. These are the various types of diseases we segregated according to the organ systems which that parasite is recognized in different patient or individuals. Conclusion, we concluded that due to complex life cycle and adopted pathological alterations of Toxoplasma gondii, the cellular immunity will get susceptible for triggering several diseases in immunocompromised individuals. Because of this reason, that person who got infected with the Toxoplasma, it is very difficult to diagnose in early basis, as well as the treatments are very difficult to uh, go for further suggestions in early basis. Currently, my research topic is on neurodegeneration. We are looking into the to extend the investigation by alterations in cellular mechanism by following in vitro T1 infection studies. The study will be further extended to focus majorly on neurological diseases against the Toxoplasma gondii infection by using human neuroblastoma cells in vitro. These are the references. Totally 132 reference I have studied, but here it is impossible to keep all the references. That's why for evidence purpose, I have mentioned the recent reports which I have read and I have prepared the review. So here I already underlined the main themes of this Toxoplasma gondii infection in central India, in its influence in central India. Toxoplasmosis, a global threat. Toxoplasmosis and hemodialysis patients, which is related to the renal failures or kidney-related diseases. Toxoplasma gondii and autoimmune diseases and cancer patients and chronic liver diseases. These are the few strong evidences for my study, which I mentioned only few instead of keeping all the 132 references. So others are very humble to thank ICHE-2023 organizing team for providing an opportunity to present this work in this conference. Thank you very much.
Okay. So you have taken the update of the review from up to 2021, I think.
No, ma'am, 2023.
Okay, so you have seen the references for the 2023 also.
Yes, ma'am.
They were not mentioned in the slide, na? Not a. After 2021, there is not a single paper you have shown there.
Yes, wait, ma'am.
I think.
Just actually,
Okay.
I mentioned, ma'am, but
okay, so
I
you have
mentioned, ma'am,
mentioned.
23.
Okay.
Here, ma'am, first one, 7th, ma'am.
7th slide.
Seventh point, ma'am. Treatments of mycobacterium tuberculosis and Toxoplasma gondii with the selenium nanoparticles.
Okay. So, do you think this kind of this Toxoplasma gondii can also transmit through the lactating animals?
Sorry,
That
ma'am,
there
I
is
did not
some
get.
kind of. Do you think that this Toxoplasma gondii can
Yes,
also transmit by the lactating animals through the milk? The milk we are consuming from the animal.
No, ma'am, no. From milk there are no reports, and it has been not proven yet.
No, there
From
is.
improperly cooked milk.
Okay, so that's what I am telling you, that in 2023 there is one report, that is Brazilian Journal of Biology. You can see it later on.
Yes, ma'am. Okay, ma'am. Thank you, ma'am.
There is one slide and one paper that is showing the Toxoplasma gondii in lactating animals that is having the potential risk to milk consuming populations. So you should incorporate that also.
Okay, ma'am. Sure, ma'am.
Okay. So that is an update from the 2000 to 2023.
Yes, ma'am.
Okay. Okay, thank you, dear.
Thank you, ma'am. Thank you so much, ma'am.
Okay. So next is, I think, Divya Malik, a postgraduate student. Divya is there?
Yes, ma'am.
Okay, Divya. You may
I
start.
hope my screen is visible.
Yes.
Okay. A very good evening to one and all present here. My name is Divya Malik. I am a student of MTech Food Technology from Jamia Hamdard University, Delhi. My poster presentation topic is systematic review and meta-analysis of medicinal properties of Lentinus edatus, which is also known as shiitake mushroom. Shiitake mushroom are a type of edible fungus that have been cultivated in Asia for centuries. They are known for their delicious flavor and unique texture, but they also have a number of potential medicinal properties like anti-inflammation and antiviral capacities. Here is a list of compounds concluding how nutritionally dense this variety is. Moving on to the objective of my studies, this study focused on in vitro and clinical trial implicated in humans, published in past 10 years. Objective of this study are a review advancement in medicinal application of shiitake mushroom, establish research gaps in medicinal studies. So the methodology that I've used for this review study is PRISMA methodology, in which total 234 records were identified from database of PubMed. Then records were identified for duplicate study and they were excluded. Total 234 records were further screened to obtain 75 studies. These 75 studies were assessed for their full text to exclude 53 studies due to various reasons as listed in the flowchart. And at the end, 22 studies were included for this systematic review and meta-analysis studies. Moving on to the result and discussion. After assessment of all the available literature, these are few results which have significant data interpretation and correlation with action of medicinal properties on humans. First would be antiviral properties of shiitake mushroom. Severe acute respiratory syndrome, coronavirus 2, is a variant of COVID-19 which causes respiratory illness. Various studies with polysaccharide extract as well as crude extract of this mushroom is used to conclude that the extracts show anti-inflammatory properties and regulates immune systems. Such studies were also done on influenza virus, hepatitis virus. Here the extract of this fungus inhibit the entry of virus into host cells by activating immunoresponse. I hope I am audible. SI in adenovirus and herpes simplex virus 2, which is basically selectivity index, was also identified in some of the research. Moving on to some of the outcomes related to human clinical trials that I've reviewed. This mushroom extract also has shown improved immunity by regulating IgA and NKT cells in 4-week clinical trials on 52 healthy male and female, which were aged between 21 to 41 years. It has also shown hepatocellular carcinoma reoccurrence, prevention of hepatocellular carcinoma reoccurrence by the use of AHC extract, which was extracted from this fungus. It has also demonstrated antioxidant activities in clinicals where it has regulated NO and Thyroid. Moving on to the antioxidant properties, meta-analysis of various research papers concluded that different extraction process varies DPPH radical scavenging IC50 value of the extract obtained. Finally, for concluding this study, here are some research gaps that has been identified by a review of various research papers. In vitro and clinical trials for cardioprotective activity of this mushroom, which will contribute to health care of increasing CVD patient, should be done. Cold plasma dried mushroom safety and in vitro studies may be done, as a cold plasma technique is a non-thermal processing to prevent loss of active compounds. Another gap that I identified was synergetic immunomodulatory studies on formulation containing shiitake mushroom may be done, so that its effect on human health can be understood. That's all from my side. Thank you.
Hello.
Yes, ma'am.
Hello.
Yes, ma'am.
Okay. So, Divya, can you tell me that how you have selected the mushroom?
Ma'am, actually,
Why you
I
have
have.
selected this mushroom?
Yes, ma'am. Am I audible?
Yes.
Yes. Okay. Ma'am, there are various like medicinal mushroom in the available, but particularly shiitake mushroom has been a focus of uh, for like medicinal properties and medicinal property evaluation for a very long time. So I thought there would be a requirement of systematic review and meta-analysis for this particular mushroom.
Okay. So you have written a review around this, I think, or you are starting you are thinking about starting some kind of research on this mushroom.
Actually, it's sort of a review only,
Oh, yeah.
systematic review and meta-analysis, which basically explains that what all research have been done in this on this mushroom, and what are basically the gaps where we can further study.
Okay. So you are not doing some kind of lab work on this?
No, ma'am. Currently, I'm not, but I'm planning to do. So,
Okay. Okay. Thank you, beta.
thank you so much, ma'am.
Okay. So next, Dr. Priyanka, next. Dr. P. Jaya Bharti.
So good afternoon, madam. I am Jay Bharati, as Department of Mathematics, Bharat Institute of Higher Education and Research, Chennai. My topic is a predictive model of carbon dioxide removal from fuel gas by the microalgal Chloria vulgaris for using photobioreactor. Overview: the mathematical formulation of the problem, analytical expressions of concentration, result and discussions. Result and discussion and conclusions. A mathematical formulation of the problem. This is all the first order nonlinear differential equations. This x of t is an cell concentration, and SL is an SL of t is an carbon dioxide concentrations of liquid phase, and Sg of t is an carbon dioxide of gas phase, concentrations of gas phase. The time changes of X, SL and G, Sg. A is an gas interfacial area, and Kl and Ysx is an mass transfer coefficient, and Y S by X is a wheel substance, and H is an Henry constant, and Ki is an incubation constant, and Ks is an Michaelis-Menten constant. This is all the notation we have to use. This is a non-linear differential equation. You can apply the mu of t here, means that SL of t and SL of t plus SL the whole square of t is a non-linear differential equation. I have used the analytical solution for using the methods in new homotopy perturbations method. This is the initial conditions for the above the three equations of here. The t is time t equal to 0 means here S is equal to S naught. The time t equal to 0 means you have to use that SL is what is a liquid phase concentration equal to SL of 0, and t equal to 0, the gas phase concentration equal to Sg comma 0. So I have using the analytical expression for using the new homotopy perturbations method. This is all this our research here. That Ks is an mass transfer coefficient. K is a Michaelis-Menten constant for increasing. Our cell concentration is also be increases. Ki is an incubation constant here for this and decreases. The cell concentration is also be decreases, and the mu x is in a specific rate here for this and decreases. The cell concentrations are also be decreases. This is all the comparison result. I have compared the numerical and analytical result. This is all the experimental values I have used that solid line is denoted that the numerical simulation, and dotted lines is represent the analytical solution. Next we have to see that the liquid phase here. So here liquid phase, the weed coefficient of increases, the cell concentration is also be increases. Here Ka is the incubation constant. Here it decreases, our cell concentrations of liquid phases also be decreases. So the comparison, I have compared the numerical and analytical result for the liquid phase. This is all the experimental values I have used that. I have using the analytical result for new homotopy perturbations method. Next, we have to see the gas phase concentration versus time. For here, that Ki is the incubation constant for decreases. So our gas phase is also be decreases, and A is an interfacial area. Here for the decreases, the gas phase is also be decreases. I have used, this is all the experimental value. I have used that. This is all the notations I have used. This is all the value I have referred the original paper. So for the conclusion, we derive the analytical expressions of concentrations of cell, liquid phase and gas phase for all the values of parameter. Analytical solutions of nonlinear equations, reaction equation has been obtained. The new homotopy perturbations method approaches derive the closed form of analytical expressions of cell, liquid phase and gas phase. The analytical results are compared with the numerical results, which are good in agreement. The analytical results have analyzed the effects of the parameter that A is in a gas liquid interfacial area, and KL and YSLX is in a mass transfer coefficients and wheel coefficients and Henry constants, and Ki is in a incubation constant. This is all the reference, and thank you.
Hello.
Hi, ma'am.
So, hello, Dr. Jaya Bharti.
Yes, ma'am.
So, how you have obtained this analytical data? From a software or like something else?
Yes, ma'am. I will compare the numerical result. If your numerical result is the correct or no, not, I don't know that. So then only I have used that analytical result. I have using this method for new homotopy perturbation method. It's easily to compare that and easily you have to do that method. Then only I can choose the new homotopy perturbations method. This is a first order equation. So then only I have easily taken. So if it is in a second order equation, means I have used so many methods. I have used that Adormin Taylor series method, Akbar Kandiji method. So first order, so I have used that this method.
Okay, very nice, ma'am. So
thank you, madam.
Okay,
okay ma'am. Thank you, ma'am.
Thank you, Beta. So next is, I think, Sachin Tanaji Mane. Sachin Tanaji Mane, is he here?
Sachin sir, are you there? Sachin Mane sir.
Hello, I think he is not here. So you can start with Sonal Verma.
He has joined, but he is not responding.
Okay. So we can start with the Sonal Verma first. You can contact him.
Yes, ma'am. Ma'am, is it visible?
There is visible, that is room number 5. This is visible.
Ma'am, I have shared my screen, but it says your screen share is loading.
Okay, I think Dr. Jia Bharti hadn't closed her screen. Her screen is showing.
Ma'am, is it visible now?
Yeah, now it is visible.
Good evening to all the respected chairperson, professors, seniors,
And all my colleagues. I am Sonal Verma from Kumar University.
Uttarakhand. The topic for my poster presentation is comparative study of the synthesis,
Biological and catalytic activities of zirconium 4 complexes derived from N and O donor shift bases.
Zirconium has a strong coordination ability with oxygen and nitrogen
Containing ligands due to its high charge to size ratio.
Their complexes are used in many biomedical
Applications including dental implants, artificial joints for limb, knee and hip replacement, and adjuvant for antibody production. They exhibit an exceptional capacity to synthesize a stable metal organic complexes with shift bases, showing cytotoxic, antimicrobial, and catalytic properties. Shift
bases also have a broad range of
application including chemosensors, polymers, stabilizers, food industry, dye, pigments, catalysis, biological actions, fluorescence, and many more. The purpose of this poster is to develop a fundamental understanding of coordination between shift base and zirconium metal ion for catalysis
and biological application.
In recent years, there has been plenty of research in the field of synthesizing zirconium 4 complexes using shift base as a ligand, which has produced a wide range of complexes with different structural characteristics.
Today, zirconium complexes
Can be synthesized from shift base derived from salicylaldehyde, benzaldehyde, isothene, acetophenone, amino acid, semicarbazide, carboxyldehyde, and many more.
Zirconium complexes of salicylaldehyde derived from shift base is synthesized by several researchers such as Salma Abdul Redhabaz
and their co-workers synthesized and characterized new zirconium complexes with shift-base ligands prepared by condensation of salicylaldehyde with azo compound. In China, 6 new zirconium complexes with monocyclopropyl and tridentate shift-base ligand were synthesized by Chen and
their co-workers. Bunser and their co-worker have
also reported an entirely new novel class of homo and heteronuclear coordination complexes of zirconium. Zirconium complexes of benzaldehyde derived in shift base also synthesized by some researchers such as complexes with some researchers by the condensation of substituting with diamine, substituted benzoic acid, and different amino acids and the zirconium complexes by the synthesis of shift-base ligand with chloride form of zirconium.
Same as them, zirconium complexes of acetophenone, amino acid,
semicarbazide,
carboxyldehyde was also synthesized. Now in field of catalysis, shift-base zirconium complexes are efficient catalysts both in homogeneous and
heterogeneous reaction. And with the type of ligand, many of these complexes exhibit high catalytic activities and have been found to catalyze most of the polymerization reactions,
enabling to produce synthetic polymers
with the required molecular weight.
Further, in biological properties, there were multiple reports recently published about the biological activity of zirconium 4
complexes that are synthesized by the combination of nitrogen and oxygen donor ligand with remarkable biological activity. A few of the properties
shown by the zirconium complexes are antibacterial, antifungal,
anti-inflammatory, and larvicidal activities. Further, we concluded that
shift base with oxygen and nitrogen sites have been
revealed an excellent ligand for the synthesizing zirconium 4 complexes.
Our data reveals an exciting progress
which will be made in synthesizing new zirconium complexes and finding their application in the field of catalysis industry. Biology could be a suitable strategy to develop novel therapeutical tools for the academic, industrial, and medical fields. Thank you.
Hello. again
Yes,
under on
ma'am.
a repeated, I think. Huh?
Yes, ma'am. Ma'am,
Okay.
currently I'm working on the synthesis of zirconium complexes on my laboratory.
Okay.
That's why I gone through this review.
Okay. Nice. That is very nice. So you have established what kind of zirconium shift basis?
Ma'am, I'm working on shift base, amino acid based shift basis, and
Okay.
Yes, ma'am.
So have you gone through a paper that is given by synthesis and characterization
no, ma'am.
research
Right now,
service?
yeah,
Okay.
ma'am, can you please repeat?
Okay. So 8 coordinate zirconium shift basis.
Yes, ma'am.
Okay. That is good. So you have done the classes with uh, these zirconium based shift bases also or not? You are
Ma'am,
only in
can
the
you?
synthesis of this.
No, ma'am. Right now, I'm synthesizing the complexes. Further, I was thinking to, uh, ma'am, to send your samples for catalysis and biological activities.
And I'm also trying to
Biological
send them for
activity.
X-ray crystallography also.
Okay, that is nice.
Yes, ma'am.
So you have to go through that
Yes,
catalysis factors.
yes, ma'am.
Okay. Okay, thank
Okay,
you.
ma'am. Thank you.
Okay, ma'am.
Olympiad.
So next is I think Ravinder Singh. Dr.
Hello,
Priyanka, have you contacted the Sachin Banerjee Mane? Is he responding now?
Yes, I am here, madam.
Okay. So would you start first?
Yes, I can start.
Hello.
Okay.
Hello.
Hello.
Hello, sir.
good
Can I
So
evening.
start?
sorry. I think
Ma'am,
Dr. Ravinder have already started.
Okay, thank you.
He's a PhD research scholar. After that, you can start, Dr.
Oh,
Mane.
hello.
okay, 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 ma'am. Okay.
Okay.
Hello. Thank you, ma'am. Good evening.
Good evening.
So, madam, my name is Ravinder Singh. I am a research scholar in the Department of Physics, Maharishi Dayanand University. And my research topic is conducting polymer-based nanocomposite for sensing application. Today, I am going to present a poster presentation. Porous polyethylene hybrid phase amines to phosphorus doped graphene nanocomposites for room temperature ammonia sensing. Ammonia, first of all, ammonia is most commonly used chemical in industrial process such as refrigeration, chemical manufacturing, cleaning agents. The accidental leakage of ammonia can pose significant safety and health risk at worker working in such an environment. And, and limit of ammonia, minimum limit is 25 ppm, above which it is dangerous for human health. Therefore, an efficient ammonia detection system has high detectivity, identification, and quantification ability, which alarm the leakage of gas safe and timely evacuation of personnel for exposure. Hence, why this is in this study, we have successfully fabricated the polyethylene nanocomposites such as polyethylene MS2 hybrid phase and phosphorus doped graphene nanocomposite sensor detection for ammonia vapor. In experiment section, the nanocomposites have synthesized by XRD diffraction, FSM, and electric characterization of sensing application. And in XRD spectrum, uh, nanocomposite XRD spectrum nanocomposites have shown the reflection observed at 20.4 and 25.43 refer to pristine polyaniline corresponding to periodicity parallel and perpendicular to the polymer chain. The presence of highly ordered structure of porous polyaniline is responsible for the observed peak at 9.4 and 14.3 degree. The XRD pattern of solution synthesize binary composite MOS2 molybdenum disulfide and phosphorodiamide. Phosphorus graphene emerge as significant diffraction peak at 9.1. 9.1 and 18.2 and 13.1 at 58.53 degree. The object peak may be ascribed to the crystallographic plane of 002, 004, 100, and 110. The hybrid phase to FSM images of ternary composite demonstrate the uniform intercalation of hybrid phase MOS2 described in this flower-like morphology, and phosphorus doped graphene is seen like in this region, graphene layer with polyaniline in figure B. And in figure C displays the ternary and composite, demonstrate uniform intercalation of ternary composites. Here is in this region we can see MOS2, and in this region this is polyaniline, and this is graphene layer. And in figure D, which we show that sensing response of ternary composite, and this is binary composite, and this is MOS2 and phosphorodifraction, and this is individual polyaniline response towards ammonia sensing at 60 ppm. In figure D, we conclude that the dynamic sensing response curve shows the sensor response at 60 ppm of ammonia exposure. The observed response and recovery time, this is the response time, and this is recovery time of sensor was 12 seconds, and response time was 12 seconds, and this is the recovery time 30 seconds, which is very good. In this one, we have successfully synthesized the ternary composite for ammonia detection. It has a maximum response toward the ammonia sensor, which is the ternary composite, other than the binary composite, and this is bare polyaniline. Hence, the ternary composite have maximum sensing response toward the ammonia sensor, which is promising candidate for developing a high efficient ammonia sensor for future generation sensor technology. Okay, ma'am. Thank you. Hello.
हाँ जी
Hello. Hello, ma'am. Am I audible?
hello
Hello, ma'am.
हाँ जी can you hear me on my voice? Hello.
Hello.
अच्छा वो phone Yeah, can you hear me?
Hello.
हाँ जी I can hear you. Is my voice audible? Is my voice audible?
Yes.
Okay, Ravinder, there was some issue, I guess, in the network. I missed what was the method of synthesis of your nanoparticles, nanocomposite? I able to hear me.
Hello, ma'am.
Um, is not able to hear me, can we proceed further then?
Yes. Ravinder sir?
ਮੈਨੂੰ ਲੱਗਦਾ ਫੋਨ ਦੇ ਵਿੱਚ ਉਹ ਹੀ ਨਹੀਂ ਆ ਰਹੀ ਹੈਗੀ ਨੈਟਵਰਕ ਦੀ ਪ੍ਰੋਬਲਮ
Ravinder sir, you are not audible, sir. Ravinder sir?
I think network issue is there.
Ravinder sir, are you there?
ਹੁਣ ਉਹਨਾਂ ਨੇ ਨੈਕਸਟ ਸਟਾਰਟ ਕਰ ਲਿਆ ਪੂਜਾ ਦਾ Am I audible now?
Yes, ma'am. Yes.
Okay, sorry for the inconvenience. Actually, there was some network issue. Ravinder ji, I actually missed.
Hello.
Can you please repeat that? What was the method
Hello,
of
ma'am, are you there?
preparation of your nano composites?
Hello. Hello, ma'am. Hello, ma'am. Are you there? Hello. Am I audible?
You are audible,
Yes,
sir.
you are audible.
Ravinder sir, you are audible. Ravinder sir? Ravinder sir, ma'am is asking about the nano composite. Am I audible, sir? Kirandeep ma'am, I think there is a network issue from his side. Am I audible, ma'am?
Yes, ma'am, you're audible. Am I audible?
Yes, ma'am, you are audible.
Okay. I was asking, that's okay. We can proceed further. Actually, I was just asking Ravinder ji if he can mention what other analytes he have used apart of ammonia. Apart of ammonia, has he checked any other analytes for the same composites?
Ravinder sir, are you there?
No issues, man. We can proceed further, right? Chinta ji Mane was
Okay.
about to start his.
Yes.
Okay,
Can I
ma'am.
start?
Okay. Now you can share your
Yes.
screen.
Yes, I'm sharing screen. Can you see slides clearly?
Yes, sir.
Hello, ma'am.
Yes, yes.
Yes, okay. I'm Dr. Sachin Tanaji Mane from Dr. Patangrao Kadam Mahavidyalaya, Shivaji University, Kolhapur. So I'm working in synthesis of polymer for CO2 gas capture. In this field, I have published this work, fabrication of microporous polymers for selective CO2 capture. In this, we have studied the significant role of cross-linking and cross-linker length. What is the use of cross-linker and cross-linking length? We have studied in this paper, and we have published this work in Journal of Material Chemistry A in 2017, and impact factor is 11.9. So this is the paper that we have published, fabrication of microporous polymers for selective CO2 capture, the significant role of cross-linking and cross-linker length. Here I am the first author. So this is the scheme of the my work. So in this work, we have prepared 3 different polymers, and we named these polymers as NUT5, NUT6, and NUT7. NUT means Nanjing University of Technology. So we prepared these 3 polymers by using 3 different monomers. For synthesis of first polymers, we have cell polymerization of TCM. For NUT6, we have used TCM and DCX as monomers, and for NUT7, we have used TCM and BCB as monomers. So in these three polymer, NUT5 is cell polymerized polymers, means without cross-linking. In NUT6, we have used the cross-linker DCX, means that is the small cross-linker, and for NUT7, we have used the BCB as a cross-linker, which is a longer cross-linker. So in this way, we have prepared these 3 polymers, NUT5, NUT6, and NUT7. So this is the surface area, pore size, and pore volume data. We can see here. Here are the 3 polymers, NUT5, 6, and 7, and BET surface area is mentioned here. 771 meter square per gram is the surface area of NUT5. 1137 is the surface area of NUT6, and NUT7 shows 987 meter square per gram surface area. Similarly, there is a pore volume and pore size data. So this is the CO2 adsorption isotherms of 3 NUT polymers at 273 Kelvin and 298 Kelvin. At two different temperatures, we have studied CO2 adsorption isotherms. So we can see that NUT6 polymer shows high CO2 adsorption than NUT7, and NUT7 shows high CO2 adsorption than NUT5. This is because of the use of the cross-linker. So this is the selectivity data, selectivity of CO2 over CH4 and N2. This we studied 3 different gases: carbon dioxide, methane, and nitrogen gas. We have studied these 3 different gases: CO2, CH4, and N2. And here is the selectivity data of the CO2 over CH4 and nitrogen gas. We can easily see that all 3 NUT polymers shows high selectivity for CO2 gas over CH4 and En2. This is we have compared our CO2 adsorption data with literature data. Here first written NUT6 and then written all the literature data. And we can easily see that here CO2 N2 selectivity is 541 and 338, and CO2 CH4 is 4864. We can see easily the adsorption amount of CO2, 4.7 millimole per gram and 3.7 millimole per gram at 2 different temperatures, 273 and 298 Kelvin. The surface area is, you can see easily, 1138 meters square per gram. And we have compared this our data with literature data, and we can easily see that our data shows high CO2 adsorption and high CO2 CH4 and CO2N2 selectivity. Here the cyclic adsorption of CO2 on NUT6 polymer. We have conducted 10 cycles for CO2 adsorption. Here we can easily see that there is no drop of the CO2 adsorption for 10 cycles. All 10 cycles shows same adsorption data. So we can easily say that polymer shows excellent adsorption capacity. Thank you. Hello, ma'am.
Yes, Dr. Mani, very nice presentation and very nice work. Am I audible?
Yes, ma'am. Thank you.
Okay, and very good recognition for your university, right?
Yes.
And sir, you have obviously worked, but it is also evident from the publication you have got from it, right?
Yes.
So you have published this work in 2017, right?
Yes, Journal of Material Chemistry A.
So you till now you haven't presented it in any other conference?
No. It's first time presented.
Okay, so it means you are having so many publications that iska time hi nahi aaya, right?
Yes. I have around 40 publications, first author.
Okay. In what period? In a period of time?
Last 5 years.
Okay, that's very nice. Okay, sir. So that was very nice. Can you please go back to your slides, please?
Yes.
To the synthesis portion, maybe.
This one, okay.
So can you please explain the synthesis?
Yeah, this is the Friedel-Crafts reaction. I have written upper side. Fabrication of nut polymers by the Friedel-Crafts reaction. So in this way,
you using a Lewis acid, a ferric chloride, yeah?
Yes, ferric chloride.
Okay. So you used it, or you have tried it with some other also?
No, I did not tried other way. I tried only the direct Friedel-Crafts
Obviously,
reaction. So
okay, because your motive would have been for fabricating of materials, right? That's why.
Yes. And DC is the solvent.
Okay, sir. So what do you guess if we use, in place of simple benzenes, if we use heterocyclic anilines, then what may be the results?
The result may be more, but selectivity will increase. In that case, selectivity will increase, but CO2 adsorption will decrease.
Okay, you have tried it, or
yes, I tried in different papers. I tried in different papers.
Okay. ठीक है,
yes.
sir. That's nice. Okay, thank you.
Okay, thank you, ma'am.
So can we proceed further with Kanika Seni?
Yes, ma'am, I'm here.
You may please start.
Yeah, ma'am. Just a minute. Okay, is my poster visible, ma'am?
Yes.
Okay, so very good evening to all. My name is Kanika Seni, and I'm working as Senior Research Fellow at CIAB Mohali under the supervision of Dr. S. Sarvana Murugan. So, I think all you might have known that amines are the important class of nitrogen-containing compounds having wide range application in pharmaceutical, agrochemicals, and many others. And particularly these days, the bio-based amine, as they can be obtained from the biomass-derived substrates, are getting a great deal of attention. So my title today is entitled as the catalytic reductive amination of bio-based furfural to furfurylamine. So as you can see here, this is the structure of furfurylamine, and you can see in this side in the application section, this furfurylamine is used either as an intermediate or the starting material for the formation or the production of these pharmaceutical compounds. Also, this furfurylamine can be converted to 3-pyridinols, which have huge application again in the formation of these pharmaceutical compounds, and also it can be used as additive in the agrochemicals. So from this we know that furfurylamine has a wide range of application in the pharmaceutical and agrochemicals. So for the production of this furfurylamine, in our lab we have synthesized 2 types of zirconium oxide based catalyst and loaded it with the ruthenium. As you can see here in the entry number 3, when this ruthenium on T-ZrO2 is tested for the reductive amination of furfural to furfurylamine, it has given a quantitative yield of 98.7%. On the other hand, when ruthenium on MZrO2 is tested under the similar condition, it is resulted into the formation of only 7% of the required product. So you can see here both are zirconia, but of different type are giving different yields. So the question arises, what is actually required, or what is so challenging in this reaction that only one type of zirconia is active but not the other? So if we see at the reaction mechanism part, what happens? This furfural reacts with this ammonia, which we use during the reaction to give this imine intermediate, and the hydrogenation of this imine intermediate in the presence of catalyst converts to this required product. But then because of its more high nucleophilic character, this furfurylamine formed during the reaction again reacts with the rest of either furfural or this imine intermediate to give this Schiff's base. Now this conversion of this Schiff's base back to the furfurylamine is the challenging part. And from the results, we came to know that ruthenium on TZrO2 is efficiently converting this Schiff's base back to the primary amine, but ruthenium on MZrO2 is not capable of doing that efficiently. So to know about the discrepancies in these catalytic activity, we have done the different characterization techniques. Like first, for the structural and morphological analysis, we have done the XRD, and from the XRD pattern, we can see here the ruthenium on MZrO2 shown completely the monoclinic phase of zirconia. On the other hand, the ruthenium on TZrO2 shown completely the formation of the tetragonal phase of zirconia. It means the tetragonal phase is more active as compared to the monoclinic phase of zirconia. For the morphological analysis, we have done the SAM analysis, and the irregular morphology of the material has been observed. And further, from the ADX mapping, we can see here the nice dispersion of ruthenium onto the support is observed in the best catalyst. Also, from the HRTM images, we came to know the particle size of zirconia in this case is around 4.56 nanometer with a D-spacing of 0.293 nanometer, which is corresponding to the 111 plane of the tetragonal phase of the zirconium oxide. Further, to know about the difference in the catalytic activity, we have done used XPS to know about the oxidation state of the metal, because in this type of reaction, the oxidation state matters a lot. So from the ruthenium 3P XPS, we can see here the ruthenium is mainly present in the 0 state, which is required for the hydrogenation step so that it can convert this imine intermediate efficiently to this primary amine. Further, we have done the zirconium 3D XPS as well. And when we compared both these two catalysts, that is ruthenium on TZrO2 and ruthenium and MZrO2, we came to know in both the catalysts, the zirconia is present only in the +4 state. But what happened is, in the case of ruthenium in TZrO2, it is shifted later towards the higher binding energy compared to the ruthenium on MZrO2. As we can see here, 0.23 electron volt shift in the case of TZrO2 towards the higher binding energy. It means that the zirconium oxide, which is there in the tetragonal phase, is more electron deficient, or it is more active compared to that ruthenium on MZrO2, which is contributing to this activation of this Schiff's base, and which is on the surface of the catalyst is getting converted back to this furfurylamine in the presence of ammonia and hydrogen. So from this study, we have concluded that ruthenium on TZRO2 exhibited higher catalytic activity towards reductive amination of furfural and giving a near quantitative yield of furfurylamine, whereas ruthenium on MZRO2 is giving a small amount of yield. The higher acidic character of ruthenium on TZRO2 facilitate the significant substrate adsorption, contributing to its higher catalytic activity. Also, we have done the poisoning study, like we have put it some poison like KSCN to kill the acidic sites of the material, and we have seen here a sharp decline in the catalytic activity, like almost zero yield of furfurylamine has been observed, indicating the acidic sites plays a decisive role towards the formation of the furfurylamine. So with this, I have concluded my study. And at last, I would like to acknowledge the CIAB Mohali for providing the research facility, UGC for the financial support. And I would like to thank ICHE Mohali for my PhD registration, and definitely the ICHE and Delhi University for the giving me opportunity to present my work on this platform. So thank you.
Yes, Kanika, very nice. So, am I audible?
Yes, ma'am.
Okay, so is your work published?
No, ma'am. This is almost the manuscript is ready, and just we are doing the final touches to the manuscript, and we will submit it within, I think, within this month.
Okay, so the difference in the catalytic property, you owe it to the difference in the oxidation state?
It is because of the acidic nature of the support, because the TZRO2 is more acidic, so it is allowing this Schiff's intermediate to adsorb efficiently on the surface of the catalyst. Because in heterogeneous catalyst, it is very important, like your substrate should adsorb onto the catalyst first, and on the surface, then reaction happens, and then it convert to the required product. So if the material is not capable of adsorbing the intermediates, then it will not convert to the required products. So that acidic sites present in ruthenium in TZRO2 is contributing to the furfurylamine production in that case.
Okay, yes. So is anyhow the size of your particles playing any role for the same?
No, actually, I have checked with the ruthenium on MZRO2 also, because in the case of MZRO2, the particle size is around 9 to 9.2 something, if I remember correctly. Yes, it was around 9 to 9.2. And in this case, the best one, it's 4.56. Also, I have tried to modify this tetragonal zirconia further to smaller or bigger particle size, but it doesn't show any particular difference in the catalytic activity.
Okay, so these furfurals are actually very much sensitive towards polymerization, right? They tend to polymerize very weirdly, right? So
yes,
is there any better results with these catalysts towards polymerization to prevent it?
No, actually, I have tried some of the substrates which are like this one is with one aldehyde only. I have also tried the substrate with which are having other sensitive groups also, but they are the catalyst is luckily giving only it is selective for the production of primary amines only.
I mean, you have only tried that with furan or with thiophene or pyrrole also?
Yeah, that I have tried. But
okay,
it is not giving a polymerized product. That's what I'm saying. It is giving corresponding primary amine only.
Okay. ठीक है. They're very nice. Thank you.
Thank you.
So thank you, Dr. Priyanka. I guess we are done with all the presentations, right?
Yes, ma'am.
Okay, so.
Okay, thank you so much, ma'am. On behalf of organizing, I'd like to extend my heartfelt gratitude to our esteemed chairperson, Dr. Kirandeep Kaur, ma'am. Thank you, ma'am, for accepting our invitation and for being here with us today. I thank all the participants for sharing their work and helping us make this event a grand success. I also thank our technical team members and our student volunteer Pooja Singh for their help and support. Thank you one and all.
Thank you, Dr. Priyanka. Thank you for your
Thank you so
invitation
much.
also.
Thank you so much.
Okay.